Continuing with Section 7, Part 2, here we look at confidence intervals when we don't know the population standard deviation. When this happens, we use what is known as the student t distribution instead of the normal distribution. T sub alpha over 2 comes from the t distribution, just as z sub alpha over 2 comes from the standard normal distribution. We find these critical t values using the t-table in Table A3, or if you have a TI-84, using the inverse t function on the calculator. Here is a diagram of the student t distribution and the standard normal distribution together. Similarly to our other methods for constructing confidence intervals, we need to find the critical t value and calculate the margin of error. Similar to the other margin of error formulas, we typically round to one more decimal than the data. Below is the procedure for constructing a confidence interval for the mean with population standard deviation unknown. Here's the table for critical t values. You can also find a confidence interval on your calculator by following the instructions listed here. An example. In this example, we have a sample of 40 individuals who did the Atkins diet. The best point estimate for this sample is the sample mean of 2.1 pounds weight loss. We are also given the sample standard deviation of 4.8 pounds. We want to construct a 99% confidence interval estimate of the mean weight loss. So this means alpha is 0.01, so we want the critical t value with a right tail area of 0.005. Now we look at the table A3 to find this value. Our degrees of freedom is 39. And the area in the right tail is 0.005. And from the table, we get that the critical t-value with tail area of 0.005 and degrees of freedom of 39 is 2.708. Now we just plug all our information into the margin of error formula. Entering the information into our calculator, rounding to one more decimal place than our data, we get the error of 2.1. Now we just construct our confidence interval by adding and subtracting the marginal error from our sample mean, the best point estimate. So we're 99% confident that the true mean of weight loss over 12 months is between 0 and 4.2 pounds. From this sample, it doesn't seem practical. Here's a cool little flowchart on which process to follow for constructing a confidence interval about a mean. Another example. For A, we have a normally distributed set and the population standard deviation is known. So this we can just use our nice z-score critical value. Example B, we don't know the population standard deviation and the data is skewed. Since the data is over 30, we can use the t-distribution. find the critical t-value, we need the degrees of freedom, which is 39. Looking at the table to see which row those values are in. And we also want the tail area to be 0.025. So our critical t-value in this case is 2.023. Example C, we can't use methods discussed here since only 9 data values and the data is skewed. Another example. Here we're looking at a sample of 12 movies and their lengths in minutes. We want a 99% confidence, so alpha is 0.01 and alpha over 2 is 0.005. Degrees of freedom is 11. We are using the student t-distribution since we're not given the population standard deviation. So we need the critical t-value with tail area of 0.005. Going to the table to locate this value, we get 3.106. Now we use our handy dandy calculator to help us get some other important information. So enter our data into our list section. Now we do the 1-bar stats on the calculator to get the sample mean and the sample standard deviation. We get a sample mean of 121.8 minutes. And our sample standard deviation of 20.4 minutes. Now we find margin of error by plugging in our information. Using our rounding rules, we get a margin of error of 18.3 minutes. Now we just add and subtract the error to get our confidence interval. Now we can say that we're 99% confident that the true mean length of movie times is between 103.5 and 140.1 minutes.